So we are going to start with creating a web application, and for this web application, we will be using a Flask. So let's start with the web application. So I'm going to start by importing the necessary libraries. So let me import. We need a Flask. We also from Flask we need to import a Flask request render template. We also need OS. Then I'll also import the necessary from SRC folder. Then from the source folder, so I'll import battery. Are going to so this one from the pipelines. So we need the prediction pipelines. The pipelines dot pip06 prediction pipeline. I'm going to import custom data as well as the prediction pipeline. Also, you're going to use the exception in from SRC rule battery rule battery exception. I'm going to import file operations error, and also we need the logging. So from SRC rule battery import a logging. So the first thing is we create a Flask app. So create a Flask app. So we can say app Flask. Then can configure a debug mode. So let's click that. So do something like configure debug mode. From here you can say if os get env. This debug mode, we are doing this, it should be best in the environment variables. So get environment, then specify the debug. Then essentially this is what we usually use I think when we going to run the Flask app, but I will not include that in that section. So I'm going to use create it separately. So from this case you can say true. Let's say app.debug debug. I think that one is, this one is okay. App.debug, that's okay. Then we create a route for the home page. So create a route for the home page. So you can say route, then we can say slash. So that's okay. Then if home, so creates a method for that. So then what we are going to return, so we are going to return render template. That's where we are going to use a template. So we are going to render a template, return a template, and that will be the home.html. So remember, under our templates we do have the home.html. So maybe this will act as an introductory page where the user interacts, maybe gets a simple message to instruct the user how to use the app or what the app is all about. Okay, so that's why we are creating this home.html. Then we can also create another route for predictions. Route for making out the predictions. Route for the predictions. Again, we can say the up route, or let's see if we are getting that description correct. The selected code is this function is used to render the home page route where the user navigates to the root URL of the application, something like the web page to welcome the user. Okay, so the home HTML template is located in the templates directory, which is a common conventional in the Flask application. The templates directory should be blah blah blah. So in summary, so the code snippet defines a route for the homepage for the Flask web application, and uses and specifies the action to be taken when the user navigates to the root URL. Okay, so from there we can now say, after some little bit of a message to the user, then we can direct the user now click this button, and it will take the user now to the predictions page where the user will now input the data. Then from there they might click the submit button, then wait for some time, then the predicted value will now appear on the screen. So let's create the route for prediction. So up route predict, a method get post def predicts data point. Let's use something predict data point. If request.method is equals to post, then we are going to return the render. Again, we use the render template, and then for this render template it will be the get. Okay, nope. Return render template is supposed to be not get, supposed to be index index.html. So index.html. So render templates index.html. Then we create the else block. So else, under the else we can now say use the try block, initiate an empty dictionary to store the results. So we are going to initialize an empty dictionary, initialize an empty dictionary to store the results. So the results, so from here in form of a form data. So we can just say, let's say something like a form data. Then we create our dictionary. Then from here we iterate over the form fields. So from here I'll just copy that. So from here we are going to iterate over the form fields. So the form fields, this represents the attributes or the features. So the cycle index, the discharge time in seconds, the decrement from 3.6 volts to around 3.4 voltage in seconds, the max voltage discharge, minimum voltage charge, time at I think this one should be 4.15 voltage seconds, time constant, and the charging time in seconds. So that's the form field. Then we are going to get a data. The data will be stored in this empty dictionary. Then from here we need to now create an instance of the custom data class. So custom data, it will receive this form data. So let's use the asterisk. Then after this, we need to convert. The form data dictionary into a data frame. Convert the form data dictionary into a data frame. Into a data frame. So remember, we created a method for this. So prediction df. So this one you can say custom data dot get data as a data frame. So remember, we created a method for this. Then we can maybe let's try to print that to see if we are getting the data itself. So this is just some sort of a debugging process, or something to see that we are doing the correct thing. Then after that, we can maybe log a message and create a log message here and say login.info. So use the f string, so form data before predictions. So form data before predictions. So this one is very important because it will enable us to see if we are really capturing the user input data. So we need to, so after we have converted that to a data frame, we are going to print. Then we can log this message to tell us that indeed we are capturing that data. So that data will be displayed in our terminal. Okay. Then we can initialize the prediction pipeline. So create an instance of the prediction pipeline class. So prediction pipeline, that's okay. Then from here, we can get the predictions. So run the prediction pipeline. So prediction, this one you can store this in a variable. So prediction pipeline. So from here we can say make predictions. So pred_df. So make predictions predictions pred_df. So that's okay. Then from here we can now return the result. So from here we can say return the render template. So instead of the index HTML, we are going to return our results in a new web page. So that web page will be the prediction.html. Okay, so predictions, and we need to use that. That's okay. So we are going. So when we make our predictions, we are going to make predictions. Now we are going to return our predictions in a new HTML file. Then we can log in our exception. So exception. Exception as is supposed to be exception as e. Login error file operation error e, and then we are going to return a render template. Maybe I can just copy this. So return a render template like this. Exception, or we can shorten this. Exception, and we just specify like this. Then I return the render template error message. Please enter valid number for all fields. So if we are having trouble with inputting the necessary values, then from here it's just as simple. We can now run our Flask application. Okay, so that's it. That's it with all about our application. So the first thing is about importing the necessary libraries and modules. Then we create something like an instance of the Flask application. Then we configure the debug mode based on the environmental variables. So instead of this, you can just maybe use here a debug to be true. Then after that, we can then create a route for the homepage. So this is just the homepage will be an introductory, something like a reception, where the user now has the interaction with the application, where they will get information about what the application really does. Then from there, they can click a button. That button will take them to the now the predictions page. The predictions page, this is where the user will be required to input some data, okay, into some fields are provided, the necessary data for that. Then after that, we are going to capture that data in the form of a form. Then we convert, create an instance of the so this is all about accepting that data. Then we can convert that data into a data frame so that it's easier for us to make the predictions. Then we can repeat that data just to make sure that we are really capturing the necessary data. Then from there we can create an instance of the predictions. We make our predictions. Then we can return the results in a new HTML file, which is the predictions.html. This is just the exception. This is just something like that pipeline that will be used to run the Flask application. So what we are missing here is that remember we need to populate our prediction.html, the index.html, as well as the home.html. So in most cases, the user won't need the train.html. They won't need to train the method by it will be only necessary for them to input the data and not to train the model. So let's I had prepared this HTML files. So let's start with the home.html. So home.html. So here we are getting this HTML. So you can see that welcome to the battery rule prediction application. This web application will help you predict the remaining useful life of a battery based on its current condition. Rule is measured as the remaining charge discharge cycles. Okay, so so I've just prepared some short message to welcome the user and maybe specify what this application will be used. Then after that, we are going to populate our index.html. So the index this HTML file will now contain, you can see we are creating, we have the style sheets. We shall remember to include that. So this is just the form data. So we can see the data that the user will be required to input. Okay, so this is the data and just something like a form. Okay, so that's it. Then we also need to include the prediction.html file. So this is the file that where the user will get the information about the actual prediction. Okay, so prediction.html. So we do have the static file. So we can create a new folder here. Our new folder will be static. So this contains the CSS code for just a little bit of styling. So under the static, we need to create a new folder. So no, a new file. So this file will be styles.css. So style.css. So let me again just copy. So this will be just about styling those HTML files. So it will pick the styling from these files from the static styles.css and try to modify those HTML files. So that's it. So let me run this Flask application to see what we will be getting from that. So we can say everything is okay. So we can say save app.py, save HTML, make sure we have saved everything so that our application runs smoothly. I think this one is okay. Okay, so you can say Python app.py. Then this will run in our code. I think I want that to run in our in this web so just give it access. Then run, I think this it will be this one. So you can just click on this, and you can see this is the home.application. So you can see welcome to battery rule prediction app. This web application will help you predict the remaining useful life of a battery based on its current condition. Rule is measured by the remaining charge discharge cycles. So after that, as you can see, we are creating this button. So start the predictions. When you start the predictions, you will be taken to a new page. So let's just so we have clicked on the start prediction button. Oops, we are getting an error. So unable to complete the request. We are getting an error. Let's see. Info making predictions. Data frame. If you have a problem with the app.py, so let me prediction pipeline. Prediction.py, so we need the app.py. Create a Flask application. So let's see if this one is okay. So prediction pipeline. That's prediction pipeline. Just cross-checking to see if everything is okay. Prediction pipeline. Plus prediction pipeline. Application.py to see if everything is okay. Let's go back and restart this. Maybe let's close this. So Python py. Okay, now it's running correctly. In terms of the data, I don't want to overshoot. I think we can just go to our rule battery. Then from here, try to enter values that are close or similar to this. I don't want to overshoot. Don't want to overshoot with my values. So as you can now see how the web application is working. So we started by going to I think it's okay. So no need for that. So let's say, for example, we enter cycle number close to 150. So we can say let's to minimize this. We can also minimize this, and let's do this. So we can start enter value close to which one? Let's use 161, 67, 89, 70. Let's use let's say cycle 120. The discharge time, cycle index. Oh, cycle, this is the cycle index, yeah. So cycle index, we can say 25, 26, 27. Let's say 120. Then we can instead of this, we can use so we can say instead of 21, so we can say 20. 20. This one is 2114. So let's say 2014.89. So decrement this one here. We can say 747.6. So we can say 760.6. Max voltage, you can say 4.001. So we can, let's say 4.0. Their max voltage, or you can say 3.999. 3.999. Okay, so that's the max voltage. It was 120. I think it is 120, 4.01. Then we can say 3.4. We can say 3.397. Then for the time, this one here, we can say 4660. 4660.38. Then time constant current, this one here, we can say 56. We can say 55, 95.4. Charging time in seconds, that will be 89. You can say 87, 35.75. Okay, so that's our data. Then we can now click the predict. When you click the predict, we expect to go to a new page. So you can see in our link /predict. Now you can now see that the predicted charge discharge cycles for the battery is 989,685. Okay, so this is now how the Flask application is working. So you can see we had the welcoming page. Then from there we went to the prediction page where we did the prediction. Then after predictions, we are getting results in the predict.html file. Okay, so that's it. So from here we can then click. Then you can go back home. Then again you can maybe start the process and maybe include a new set of data. Then maybe find do the prediction, then you can now see the predictions. So that's simple with the web application. You can now see that now this we do have a web application, and you can see that the web application is working. Okay, so we have built the web application using Flask, and the result from that you can see that it is working. So let's do some querying in our terminal. So you can see we requested that our data should be printed. So you can see that we are printing our data. You can see that we are printing our data so that we are sure that the web application is really capturing the data points that we are inserting, or we are inserting. Okay, so that's about that. Then you can see how the web application is running. So you can see that our web application is running. Okay, so that's it for this. So we have so that's it for this. We have now developed a web application that can be used to make the predictions. So this is just a simple web application. So of course, in productions you will be handling a lot of data. So maybe you need to modify your web application to now, instead of only accepting one input at a time, it should now maybe convert it to do something like a batch processing, where it might process data in where it can do the batch processing or the real-time processing, depending on the nature of the task that you will be tackling, in case you are dealing with such a problem. Okay, but for us it was just to show you how we can create a web application using a Flask that will accept user input and do the predictions. Okay, so that's it with the Flask application. In the next phase, we are going to start with the Streamlit. So I'll show you how we can apply the Streamlit, or we can create an application, a Streamlit application from the Flask application. So it will be just something like a modification. So I'm going to show you that. And probably in the next session after this, we are going to create a I think we'll use Docker to create an image for this application, and create the CI/CD for the same, so that whenever we have changes in our model, we are able to push our changes, and it will pull that image and create a new image for whatever changes that we are making. Okay, so I think by that, I think I will close the session with that. Then from there, I think we will start with the next project, which is about, I'll tell you about when we start that project. So stay tuned. See you in the next one. All right, so let's continue with the let's continue. Now we are at the Streamlit application. So we are going to create a Streamlit application. So this works almost similar to a Flask application, but we can try another application to create another application using another tool, just to have a feel of it, and see how it can be created, how it performs relative to the Flask application. So this is the Streamlit app. So if you don't know more about the Streamlit, so you can maybe Streamlit app. So maybe you can find more information about Streamlit app. So from here, you can read more about the Streamlit, faster way to build and share data applications. So you can read more about Streamlit, find out how you can use the Streamlit in your different projects. Okay. So we are going to create a Streamlit for our application. So as usual, we are going to start by importing the necessary libraries that we need. Then again, we need to import the prediction pipeline. So this is the prediction pipeline. We also need it. think as of now, we just need the prediction pipeline. Then, so we need again to create a home page. So we need to create a function. Function to display the home page. So function to display the home page. Def. So we can create that function. Can name the function show home page. Show home page. So that's the function. Then st dot something like a title. So title for that page. So st dot title welcome. Say something like welcome to rule battery prediction, something like that. Then instead of markdown, we can use write. This is the home page for the rule battery prediction application. So you can say this application can add some information. Me add this information and just add and we can just maybe use this in a new line. So this is the some information. This is the home page for the rule battery prediction application. This web application will help you predict the remaining useful life RUL of a battery based on its current condition. Okay. So after that, we can move another step. Create a function to display the prediction page. So create a function to display the prediction page. So again, show prediction page. So show prediction page. Then t.title can say rule prediction app. We need this one, rule prediction page, rule prediction page. So to display the page, then from here we need to create form for user input. Create a form for user inputs, just as we were doing with the Flask application. So we can say st.form sorry, then prediction form, form, include that column. So we can just go to our app.py and then we can copy this. Let me just copy this so that I can shorten our time. So cycle index, use shift tab, okay, so that then you can remove this. You can remove this. So cycle index. So we can say st text underscore input. So we are in text input. Then can say cycle index, cycle index. Then from here, we can now enter the value. So this is just a placeholder for that. So you can repeat the same all the way until the charging time. Let me just copy paste this. So cycle index text.input discharge, this value 0. These are just placeholder values. So I think that is okay. Cycle index discharge time decrement from 3.6 to 3.4, max voltage, minimum voltage, time at 4.15 voltage in seconds, time constant in terms of current, then the charging time. Okay, so we need to create a submit button. So I'm going to create that button. So submit button. So submit button. So submit button. So st.form underscore submit button label submit predict submit. That's okay. Then we can also handle form submission. So to handle that, we need to create this if statement. So if submit button, this one here, then whatever here should be inside this if statement. They should be aligned. That's okay. So form data. Then enter the data. So this one, the form data, should be inside here. No, clear this. And use asterisks. And need to insert the form data. Then after that, we need get the data from the user. So get an instance of the custom data. So similar to what we did in the Flask application. So create an instance of the custom data. Then convert the data dictionary to a data frame. So we need to create this is the submit button. Try prepare form data. That's okay. Then we need to create, or let me just copy that, and I'll just paste whatever I did previously. So we create an instance of the custom data. So that will take the form data that the user will input. Then we need to convert that form data into a dictionary. So convert the form data into form of a dictionary for easier predictions. So we are using the get data frame. I think this function we created in the custom data. Then after that, we need to initialize the prediction pipeline. So we use that function, the class that we created in the prediction pipeline. Then after that, we need to get the predictions. So we are getting the predictions for that. Then we can display our results. So subheader prediction results. And then we can display our results for that. Then this is just the except block, encapsulating all this under the try except block. Then we are going to use this to now execute our Streamlit application. So the main st.sidebar, we have a sidebar navigation. So navigation, we get to the home and the predict. So an application. So in the sidebar, you'll have something like a navigation where you can click home for home, then predict for the prediction. Then if page is home, then show home page, else you show the predict. Then if underscore name main, that's okay. I think label predict. I think we can just change this to predict, not submit. So I think everything is okay. Okay. This is how you you create a Flask application. This is how you create your Flask application. Something that it's supposed to be rule battery. Rule battery, if I'm not wrong. Need to copy this. Need to import the same. I think that's why we are getting that error. Import Streamlit as st. I think we need to import this, create this line and import in our Streamlit application. So I just copy this. We need to change this. I think up to now everything seems to be okay. Yeah, so let's execute the Streamlit. So if you want to execute the Streamlit application, then you'll run this command, Streamlit run. Then you need to your script.py. So your script.py is essentially I think the name of the Streamlit application. So in our case, Streamlit.run, then our Streamlit application, copy relative path. I think it's the Streamlit app.py. So you can save this to ensure everything is okay. Then run to execute. And make sure I want it to run from this here. Let's wait and see. So you can see our Streamlit is now running. You can see local URL is this, network URL is this. So our Streamlit application is running. So we can, I think you can see our Streamlit application is running. So you can stop deploy. So this is the navigation bar that I was saying. So you can see home and predict. Then in the home page, you can see welcome to battery rule prediction application. This web application will help you predict the remaining useful life of a battery based on its current condition. That is the home. Then you can go to the predict, where you can now insert your data. So here again, I'm going to use almost a something similar. So I don't want to overshoot or enter data that is not within the limits, and by that we might get exorbitant results from that. So let me be considerate. So we can say, for example, cycle 85. So 85, or we can run this in an let me execute this, then let me insert the data, and then we can just I'll show you my data. So 85, then we can use 247.58, say 20047.58, and then is 776.4. So you can say 766.5. And this one 4.008. You can use 4.001. 4.001. Minimum voltage, you can use 3.404. You can say 3.399. So 3.399. Then the time, we can use 4768. Let's use 4768.5. let's say 24. Then the time constant, we can use 5940.3, so 5940.3. And time seconds, 8962. So we can use 8962.02. Okay. So essentially, this is our data. So cycle index, discharge time, decrement from 3.6 to 3.4, max voltage, minimum voltage, time at 4.15 voltage, time constant, then the charging time. So after this, we can then click the button predict. You can see it is running. So after it's done, we are going to get predictions based on this data. It is running. Let's see if our model was actually getting the necessary data. So you can see converting the data object to a data frame, then making predictions. Let's see in our application, you can now see that prediction results. The predicted remaining useful life for the battery is 1054.94 cycles. So this is just another way that you can create an application or an interface where the user can interact with your model. So we have created a web application using the Flask app, and we are able to run that application, and we are able to get a prediction results. We have also used a Streamlit application. We have also built one application based on a Streamlit library, and we have input our data, and then you can see that we're also getting or generating a result from that. So there are just many ways that you can use. Another technique that you can use is Gradio. So recently I've seen that they have made some improvement on Gradio. So that's also another way that you can use to create a front end interface where the user can interact with your application. So you can style this Streamlit application. You can introduce new features, maybe depending on what you are going to predict or the necessary requirements. Okay, so you can style this, add new features, all that with this Streamlit. So my task was just to show you how we can use this. We can create an application using Streamlit. So with this, you can see how we can create that. Okay, so I'm going to terminate this, then possibly push this to our Git repository so that you can also have this, maybe run it on your setup to see if we can get a similar value or something like that. So git add. So in the previous session, I did not submit. So git status. In the previous one, we did not submit this one, the ones that we did with the Flask application. So git commit. So -m. So we can say Flask and Streamlit. So from here, we can just do the git push. So git push -u origin main. So with this, we can now successfully, up to now, we have successfully built our model all the way, starting from the data ingestion up to now building an front face. What can we say about that? Front end where the user can interact with the data. So this is all about our project, though I'm not going to end at this juncture. The next step, as I had told you, will be all about the Docker file, creating an image. not create the Docker. Will be about the Docker. I'm not seeing the Docker file there. We'll create the Docker. We'll create an image for our application, and possibly after creating our image, we can push our image to the Docker repository. Then from there, we can perform additional things, maybe link that to either monitoring, and we can also share our Docker image. Okay, so that will be the next step. So in that step, I will first do the whole episode about that. So it will be quite a long thing, building the image and all that, based on my computation resources. It might take time, but I will try my best to ensure that that process is seamless and faster. Then we can build a Docker image for that can be used for the battery rule application. So the Docker image, then you can share the Docker image, push that Docker to the Docker repository. Okay, so that will be the next task after this. So I think by now you have a clear understanding of how you can develop a machine learning model from the beginning. Let's say from data ingestion, if you're from data ingestion all the way until where application and possibly deployment. So I think by now, following the series of videos, I think by now you should be having that understanding as to this. So in the coming projects, we'll try to even go further. In the coming project, I think you will, the coming project, you'll see we won't be just stopping at this point. We'll go even a step further and see how we can apply that model that we will have produced into we'll create a scenario then we apply that model into a real case scenario where someone you'll get understanding. You will the next, I think starting next week, I'll be producing that. I'll start producing that project. So from there, you'll get an clear understanding as to what I'm talking about. Okay. So after this, I think the next step is about the Docker. Then I think I'll close the chapter with this. Then start a new project from there. Okay. Once again, up to this point, I'm very thankful. I'm very grateful for your support. It's your support that keeps us continue produce such a great content. It's your support that motivates us. Also, this is a learning process for us, and we would like to also include you in this learning process. So I'm going to end at this point, and then before we close, subscribe to the channel, hit that notification bell so that you never miss any of our video updates. You can also like, comment, and share with the friends so that they get to the train wagon of learning how to build these machine learning systems. With that said, see you in the next one.